I'm Mary.
I'm Jocelyn.
We are going to show you how to solve a multiplication problem. 23 multiplied by 4. This is a 2-digit by 1-digit multiplication problem. First, we will use a number line to estimate the answer to our equation. We can take our larger number, 23, and round it up or down for the purposes of estimation. We chose to round up to 25. The number 25 makes us think of money. A quarter is 25 cents. Our equation is asking us to multiply it by 4 times. 4 quarters equals $1 or 100 cents. We can count by 25 on a number line that goes up to 100 to solve this equation. 25 4 times. 25, 50, 75, 100. Our answer will be less than 100, but greater than 75. Next, we will use our base 10 blocks. We can look at this equation, 23 multiplied by 4, as 23 4 times. We can use our base 10 blocks to see 23. 23 is 2 10s and 3 1s. Let's do this 4 times. Now that we have our 4 groups of 23, we can count our blocks to solve this equation. Let's count by 10s first. 10, 20, 30, 40, 50, 60, 70, 80. We have 8 10s, or 80. Now let's count our 1s. We can count 1 at a time or by 3s. 3, 6, 9, 12. We have 12 1s. What do you notice? That's right, from our 12 1s, we can make one more group of 10. That leaves us with 9 groups of 10s, or 90, and 2 1s. Our answer is 92. Finally, we can solve this equation using an array. An array is rows, or a way to solve an equation using a grouping or an arrangement. Let's start with a simple example. 5 multiplied by 2. I have drawn 5 rows with 2 dots. If I counted each individual dot, I would count 10. 5 multiplied by 2 is equal to 10. This gets a little bit more complicated when you multiply a 2-digit number by a 1-digit number. Let's have a look at our equation. 23 multiplied by 4. We can draw a line down our equation to clearly show our place value. This equation has 10s, and it has 1s. Let's begin our array. First, we are going to draw lines to represent our 2-digit number, 23. 23 has 2 10s and 3 1s. These 2 lines represent the 2 10s, and these 3 lines represent the 3 1s. We drew a line down our equation, and we want you to think of this array as also having an imaginary line down the equation, because they are like 2 separate arrays. You are going to solve for 10s and 1s separately. Next, we will draw our second factor, the 4. These 4 lines represent 4 1s. Let's start with the 10 arrays. We can count each intersection line, or if we are familiar with our multiplication tables, we can multiply 4 by 2, which is equal to 8. Remember that this is the 10s array. This represents 8 10s, or 80. Next, we will go to our 1s array. Remember, we can count each intersecting line, or we can multiply 4 times 3, which is equal to 12. We know that the 1 is in the 10s place, so it needs to be moved to the other group. We now have 9 10s, or 90, and 2 1s. Our answer is 92.